Good day. We move on to our next type ng series, the geometric series. So as expected, this would be the sum of the terms of a geometric sequence. Now we've seen that in an arithmetic series, we can't just take the sum of all the terms of an infinite arithmetic series kasi that will always be either positive infinity or negative infinity. That is not necessarily the case for a geometric series. A geometric series can still sum up all the way to positive infinity or negative infinity, pero may specific cases na magkakaroon siya ng sum kahit all the way to infinity pa yung a-add mo. So dun muna tayo sa partial sum of the first n terms of a geometric sequence. Let's start by identifying that the sum of a geometric sequence, or the partial sum of the first n terms of a geometric sequence, is g1 plus g sub 2 plus g sub 3, and so on all the way to the last term, the nth term of our partial geometric sequence. Now, ano ba yung second term ng geometric sequence? That is the first term times r. The third term is the first term na dalawang beses nating multiply si r, or r squared. And so on. So the second to the last term is the first term multiplied by r raised to n minus 2. Kasi the last term is the first term multiplied by r n minus 1 times. I hope this is clear kasi yung first term, hindi natin minumultiply ng r. So, pag nag-start tayo mag-multiply ng r sa second term, pagdating natin dun sa nth term, n minus 1 times lang tayo nag-multiply ng r. Now, what I want to do is to come up with an equation for s sub n na hindi natin kailangang ilista lahat ng terms nung ating geometric sequence. And we can't do the trick na pinipair natin yung first and last. So, we'll have to do another trick. Notice that in these terms ng geometric sequence natin, common factor nila si g sub 1. So, factor out natin si g sub 1. So, I have g sub 1 multiplied to 1 plus r squared and so on hanggang r raised to n minus 1. Now, the trick na ginawa natin sa arithmetic sequence na ina-add natin yung first and last terms, then second to the last terms, hindi siya mag-work for a geometric series. So, we have to use another trick. And the trick here is to multiply both sides of this equation by the common ratio. So we have r times s sub n. This is just r times g sub 1 times yung 1 plus r squared plus r and so on, all the way to r raised to n minus 1. So yung r sa labas, i-distribute ko na siya dun sa parenthesis. So I will get g sub 1 multiplied to r plus r squared and so on, all the way na hanggang r raised to n. Hindi na hanggang n minus 1. Kasi multiply natin ng r lahat ng terms eh. And what I will do is I will subtract yung r times s sub n dun sa s sub n sa taas. So I label my two equations as equations 1 and equation 2. So kukunin ko yung 1 minus 2. This would be s sub n minus r times s sub n. That would be equal to the difference of g sub 1. Notice parehong may g sub 1 yung dalawang right-hand side. So, ipa-factor out ko na siya. So, 1 plus r squared and so on hanggang r raised to n minus 1 minus yung parenthesis sa baba, which is r plus r squared and so on hanggang r raised to n. Now, pause tayo saglit dito. Ano yung mangyayari that will simplify this expression? Notice that magka-cancel yung madaming terms like r minus r squared minus r squared, all the way to r raised to n minus 2 minus r raised to n minus 2, r raised to n minus 1 minus r raised to n minus 1. So parang kinumpress natin ng ganun yung equation natin. At ano na lang matitira? On the left-hand side, we could factor out si s sub n. So magkakaroon tayo ng s sub n times 1 minus r. And on the right-hand side, we'll just have g sub 1 multiplied to yung matitira dun sa mga subtractions, which is just 1 minus r raised to n. And again, we're looking for a formula for the sum. So we just divide both sides by 1 minus r, and we'll get s sub n is equal to g sub 1 times 1 minus r raised to n divided by 1 minus r. So ano yung hindi pwedeng maging value ni r dito sa expression na to? Clearly, hindi tayo pwedeng magkaroon ng r na equal to 1. Otherwise, magiging undefined itong expression. Ito magiging 0 yung denominator. At the same time, ano ba yung implication if r equals 1? It just means you're adding the same terms over and over. Parang 2 plus 2 plus 2 plus 2. Kasi the common ratio is 1. In that case, you can treat it as an arithmetic sequence na ang common difference ay 0. So, wag na natin siyang i-treat as a geometric sequence. So our formula for the sum of the first n terms, the partial sum of a geometric sequence, will be this, and kailangan nating clarify na hindi equal sa 1 si r. Okay, let's take a look at some examples. We want to find the sum of the first 9 terms of this geometric series, 2 minus 6 plus 18 minus 54 plus, and so on. I want you to pause this, and when you're ready to compare answers, unpause nyo na. Okay, so let's compare our answers. So we're looking for the sum of the first 9 terms. The first term is definitely 2. What is the common ratio? Common ratio is yung ratio ng second with the first term, with the third with the second term. So it's negative 6 over 2. It's also 18 over negative 6. And this is clearly negative 3. Using our formula, the ninth term, using our formula, the sum of the first 9 terms is equal to the first term, which is 2, multiplied to 1 minus r raised to n, which is 9, all over 1 minus r. Substituting our values, we have 2 times 1 minus negative 3 raised to 9 over 1 minus negative 3. So that's positive 4. And I think i-calculator na lang natin siya. We'll get 9,842 as the sum of the first 9 terms. And this is our final answer. For this second example, given sa atin yung first term ng geometric sequence, it's 36, and the fifth term is 64 over 9. Ano daw yung sum ng first 6 terms of the sequence? So again, please pause this, try to work it out on your own, and let's compare answers. Okay, let's compare answers. We're looking for the sum of the first 6 terms. And the first term is 36, the fifth term is 64 over 9. And we need the common ratio para magamit natin yung formula. So first, gamitin natin yung formulas ng geometric sequences to find the common ratio. So g sub 5 is equal to g sub 1 times the common ratio multiplied to the first term ng ilang beses, 5 minus 1 times, or 4. Isolating r raised to 4, this would be g sub 5 over g sub 1, or 64 over 9, divided by 36. And r raised to 4 is equal to 16 over 81. Taking the fourth root of both sides, we'll get r is equal to plus or minus 2/3. So, kailangan i-consider natin yung negative na r. Kasi even if r is negative, pwede pa rin siyang maging geometric sequence. At yung sum nila ay isang geometric series. So, we have two cases. First case is when r is positive 2/3. Substituting into our equation for the sum of the first 6 terms, the sum is the first term, 36, times 1 minus r, which is 2/3, raised to n, so 6, all over 1 minus 2/3, or 1/3. Basically, multiply natin lahat by 3. So ito, calculator na lang natin. This will give us 2,660 over 27. Medyo pangit, hindi siya some neat integer, but that's the final answer. We look at the second case, where r is negative. Same formula, s sub 6 equal to 36 times 1 minus negative 2/3 raised to 6, divided by 1 plus 2/3 this time, kasi minus, minus. So just plugging this in the calculator, we have 532 over 27. So let's ask ourselves, does it make sense na mas maliit yung value nung sum pag r is negative? It makes sense kasi yung terms are going plus, minus, plus, minus, plus, minus. So, yung sum talaga nila, dahil may minus siya, mas maliit dun sa plus, 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 plus ka lang palagi. And the final answer for this item is, first case, it's 2,660 over 27, and the second case, it's 532 over 27. Now, we mentioned kanina that for geometric series, there is a possibility na kahit infinite yung number of terms, they could add up to a finite value. Now, this is the most basic of those examples. Ano yung sum ng 1 plus 1/2 plus 1/4 plus 1/8 plus 1 over 16? Since to get to the next term, you are multiplying by 1/2 or dividing by 2. This is an infinite geometric series. And before we apply any formulas, let's do this graphically. So let's say this square ay nag-represent ng 1. Siya yung 1. So yung area niya is 1. And if I want to add it to 1/2, I'll add it to a figure na kalahati ng area niya. So itong rectangle na to. That's 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1 over 32 plus 1 over 64, 1 over 128, 1 over 256. Notice yung mga squares na maliit, sila yung perfect squares, yung denominator. So 64 is 8 squared, 256 is 16 squared, and so on. And so on. Continuing the addition of the smaller and smaller squares para mabuo lang itong square na to. So what is my total area? If this is 1, and I just have another square here with the same area as this one, then this infinite geometric series, it adds up to 2. So kahit infinite yung number of terms, finite yung sum niya. Another graphical example, you might want to take a guess before natin siya gawin. We want to add up yung powers ng 1 over 4. So we're adding 1/4 plus 1 over 16 plus 1 over 64 all the way to infinity. This is a geometric series kasi to get to the next term, you are multiplying by 1/4 or dividing by 4. And I want to first evaluate this graphically. So again, if this square represents area 1, then 1/4 is, divide ko siya into 4 squares and shadean ko yung isang square. So 1/4 yung area nung red. Now 1 over 16 is 1/4 ng 1/4. So this is 1/4 and 1/4 niya is 1 over 16 of the whole thing. So I'll shade that as well. 1 over 64 is 1/4 ng 1/16. So this is 1 over 16. I'll shade 1/4 of that. So and so on. So we'll just keep dividing the smaller and smaller squares into 4 and shading yung 1/4 nung bawat square na. And so on all the way to infinity. Anong area yung nire-represent nung red squares dito? Well, this whole big square has area 1. And notice na itong red and smaller red and smaller red and smaller red na squares, yan yung pattern nitong square, smaller, smaller, and smaller squares. It's also the pattern nitong square and smaller and smaller and smaller squares. And how many such groups do you have in this area na 1? You have 3. Tapos, isa lang dun sa 3 groups yung shaded na red. And that shaded red na part nitong square natin, that's exactly 1/3 nung big square natin na 1. Kasi 3 sets of smaller and smaller squares yung meron tayo. Another way of looking at it is you have 3 big squares, shaded yung isa. Then, second biggest square, shade 3 din, shaded yung isa. For each group of squares na tigatlo, may isang shaded. So the sum of 1/4 plus 1/16 plus 1 over 64 all the way to infinity, we've seen it to be visually equal to 1/3. So how do we reconcile this with our formula for the sum of the geometric series na partial sum lang? Now first, ilagay natin yung restrictions kung kailan ito mag-work. Mag-work lang to kung papaliit ng papaliit yung dinadagdag mo. Siyempre, kung papalaki ng papalaki dinadagdag mo, edi pupunta ka talaga ng infinity. So, an infinite geometric series will only have a finite sum. The technical term is magko-converge siya to a finite sum whenever your common ratio are absolute value, kasi kung negative yan, tapos greater than 1 yung absolute value, mag-a-add ka lang ng positive, negative na papalaki. So mag-switch ka between higher and higher positive and negative values. An infinite geometric series will only have a sum or will only converge whenever the absolute value of your common ratio is less than 1. So kahit 0.99 pa yan, 0.999 pa yan, essentially you're adding smaller and smaller terms. At aabot siya sa point na mag-a-add up siya to a finite sum. So can we derive a formula for the sum? Well, start tayo dun sa sum of the first n terms. Ito yung kanina, s sub n is equal to the first term times 1 minus r raised to n over 1 minus r. And since our r is already not equal to 1, hindi na natin isa-specify dito na r is not equal to 1. Ngayon, kung yung common ratio natin ay mas maliit sa 1 at nire-raise mo siya ng nire-raise to higher and higher powers, at infinite to. So essentially, ang last term mo ay the infiniteenth term. Walang ganun. But it's like n is equal to infinity, or papalapitin mo na papalapitin si n sa infinity, then, r, which is less than 1, pag ni-raise mo ng ni-raise to higher and higher powers, yung value ni r raised to n, lalapit sa 0. And since infinity yung n, it's essentially saying that your last term, quote-unquote, is 0. Kasi dun at dun pupunta si r raised to n. And in that case, the sum of the infinite terms, of all the terms of your infinite geometric sequence is g1 times 1 minus 0, or g1 na lang, divided by 1 minus r. Ganun lang ka simple. So let's check dun sa examples natin kanina. 1 plus 1 half plus 1 fourth plus 1 eighth, our first term is 1, and our denominator is 1 minus the common ratio, 1 half. So 1 divided by 1 minus 1 half, it's 1 over 1 half or 2. So tama yung nakuha natin. Mas maganda yun kanina, di ba? Mas may sense kasi nakita natin kung bakit siya equal sa 2. Yung 1/4 naman plus 1 over 16 plus 1 over 64, our first term is 1/4. Ang common ratio natin is 1/4. So we have 1/4 over 1 minus 1/4 or 1/4 over 3/4, cancel yung mga 4, and we get 1/3, which is consistent dun sa nakuha natin kanina. Maybe one example of an infinite geometric series for you to solve. Pause this, give me, and find the answer. Okay, now note, no? Madali lang to. Hindi na natin kailangan i-compute para makuha ko ano yung proper fraction for this one. But we want to use the idea of the infinite geometric series. Using the infinite geometric series, I could say that 0.131313 and so on is equal to 0.13 plus 0.0013 plus 0.000013 and so on. And this is an infinite geometric series na ang common ratio natin ay 1 over 100 or 0.01. So we could also write this as 0.13 plus 0.13 times 0.01 plus 0.13 times 0.01 squared and so on. So our first term is 0.13 and our common ratio is 0.01. And let's use our formula for the infinite geometric series. The sum is just the first term over 1 minus r, and the first term is 0.13 divided by 1 minus 0.01 or 0.13 over 0.99. Multiply lang natin 100 both ng numerator and denominator and we get 13 over 99, which is the final correct answer. Now let's just check using a simpler method na tinuro sa atin ng grade 7 sana. Na you just let x be equal to r 0.1313 bar. Tapos multiply natin siya 100. 100x is equal to 13.1313 to infinity. Then isubtract natin yung second equation from the first. And we'll have 99x equal to 13 or x equals 13 over 99. So tama naman. Mas mahaba pa yung ginawa nating solution. But we applied the idea of an infinite geometric series and it's supported by previous methods that we already know. So that concludes our lesson for arithmetic and geometric series. Thank you very much and see you sa next video lesson natin.